The first way to minimize the accuracy problems or the shortcomings of the basic elasticity formula would be point price elasticity. This is, we can rearrange our basic elasticity formula to calculate point price elasticity, and let's look at that right now. So the price elasticity of demand would be equal to Q2 minus Q1 over Q1, the percentage change in quantity over P2 minus P1 over P1, the percentage change in price. This can be rearranged as ED is equal to the difference in quantity over quantity divided by the difference over price over price. It's the same thing. Rather than writing Q2 minus Q1, I have put here the differences in quantity and differences in price. So this, if we rearrange it, it will be dQ over dP into price over quantity. Now here there are two parts here. This is the first part and this would be the second part. If we have a formula where it says quantity is equal to 12 minus 3p. Now when we take this 3, this is the slope. So this slope, this 3 is actually dq over dp. So we can fit into dq over dp. So in this formula, if you take the dq over dp would be 3. And this price, if you plug in what is price and what is quantity, we would find the price elasticity of demand. So let us actually do it for this formula. If you take it, price is P and quantity is equivalent to 12 minus 3P. So it will be 12 minus 3P. So elasticity of demand for this particular equation would be 3 into P divided by 12 minus 3P. So we have actually solved it. So if we know the price for any given price point, we can actually find out the elasticity of demand. So which gives us the reason point price elasticity. If you just plug in what point you want to calculate the elasticity of demand, you would actually easily calculate when we plug in this. Now the point here to note that is, when we do our demand curve, we actually plot down P in our y-axis and Q in our x-axis. But when we see the demand equation, normally it's given by quantity demand as the dependent variable and price is our independent variable, which is correct because price is actually independent and price is the one which is affecting the quantity. But when we draw the demand curve is actually P over Q. So this particular function in the demand curve is known as inverse slope. Inverse slope. Why? The reason is we have actually, in for example, this is a linear equation. So if this is the demand curve, the slope of this demand curve will not be dq over dp. It's actually the inverse part of it. But if you take this 3, this would be dq over dp because it is written q as the dependent variable and price as the independent variable. This is the only point that here to note here. So when you are given actually a demand equation and if it is the function of the quantity is written in the dependent variable, you can easily take the coefficient or the slope and plug it in as your price point equation. But in this demand curve, it would be known as the inverse slope. Since the demand curve is our reference point, we take this as the inverse slope. So this is quite easy, and we would see for a non-linear curve how does this look and how do we calculate price elasticity of demand.